Kristen Atchison here, and we're talking about Chapter 8, Memory. So last chapter we talked about learning. Memory is learning that has persisted over time, okay? So this is information that we have stored in some way and that we can retrieve when we need it. There's three kind of functions and three processes in memory. The first of which is encoding. And this is when information gets put into memory, okay? And we'll talk about this kind of throughout Chapter 8, both in this video lecture and again in class, and there's some Launchpad assignments as well. But this is again where that information is getting stored. So think of it as putting something in the filing cabinet. Storage is that maintenance of the information in memory, so that's kind of more the filing cabinet itself. And retrieval is recovering that information from memory, okay? We went and got something out of the filing cabinet. So there's these three functions, and that's the order in which it happens. We encode a memory, that memory is stored, and then when we need that memory, we retrieve it. The information processing perspective, or the Atkinson-Schriffen multiple stores model, says that there are different kinds of memory, and there are different ways in which this is happening. So one of these these multiple stores is sensory memory, and this is storing an exact copy of this incoming information. You can all have recognize a smell or a song, and it is attached to other things, okay? Again, you remember that exact copy of that sensory information. Or short-term memory, or what we also call working memory, is kind of what we're using right now. So you can kind of think of it as your desk, and what are you using right now, okay? Not what's in the filing cabinet, but what do you have out on your desk? What are you using right now? So working memory or short-term memory is where the stuff that you're using right now. So when I'm talking to you about this, I've pulled this stuff kind of out. The files are out and they're on my desk. And I'm talking to you about short-term memory. I'm talking to you about working memory. And these are things that I'm using, my information about these. And again, and we see that working memory is kind of different in different people and it changes over development. And so we see that everybody kind of has a different desk. And so we have... there's some averages that we'll see, but working memory, you can kind of think of it as the desk, which you're operating with right now. Whereas long-term memory is that permanent storage. That's that filing cabinet, okay, according to this Atkinson-Schriffen model. So here's an image of that. So the incoming information comes in. If it's a sensory memory, we pay attention to it. If we pay attention to it, then it can go into short-term memory. If we don't pay attention to it, whatever that is, whatever we're learning, whether we're reading something or hearing something or experiencing something or feeling something, if we don't pay attention to that thing, we're not going to remember it. So it's forgotten. So you can see that sensory memory comes into that green box, and if we don't attend to it, the first pink arrow, it's forgotten. If we do pay attention to it, if we do focus our attention on it, it can go into short-term memory. And again, short-term memory is this kind of desk where we're using things. If it's not coded while it's in short-term memory, if it's not something that we're trying to remember, if it's not something that gets coded in some way, it can also be forgotten here. Once it gets coded for long-term memory, it kind of goes into this storage system. And what's really nice is we can pull it back out and put it back in working memory and through rehearsal. And every time that we do that, every time we pull a memory out, every time that I lecture about this, I pull these memories out of long-term memory, and I understand them better. I rehearse them. And so my understanding of short-term memory improves every time I talk about short-term memory, because I'm both pulling it out of my long-term memory and rehearsing it by telling you about it. So again, you can kind of think of the two storage systems as short-term memory. If it gets encoded, it goes into long-term memory. If it doesn't get encoded, it gets forgotten. And then we kind of can have this back and forth between short-term and long-term memory, where these memories are encoded, that will pull them out and use them in this kind of more working memory. So again, short-term memory is going to have a pretty limited capacity. So our desk can only be so big, right? You can't have an unlimited capacity here. And we think that our current understanding is that it's about 7 bits of information plus or minus 2. In fact, we can see that one of the reasons that phone numbers, when we had to memorize phone numbers, were 7 digits, were because those were what we could remember. And we're better at doing this for numbers than we are for letters. And some of that is also through practice. That we have to kind of in our world remember random numbers, your student ID number, your social security number, your driver's license number. And so again, these are all typically 7 plus or minus 2, so that they are easier to remember. The other thing, if they're longer than that, one of the things that they'll do is they'll do chunking them. If you notice your social security number has dashes in between it, one of the reasons they do that is so that you can better remember your social security number. By chunking it, we can kind of keep that information better. So again, recall is better for the numbers than the letters. We also see that recall is slightly better for what we hear than what we see. So we see that auditory recall is slightly better than visual recall. And without rehearsal, so without trying to remember it, most people can retain information chunks in their short-term memory. So when I said we chunk that social security number, without rehearsing this, our desk is usually about 4 information chunks. So we don't have a very big desk, okay? Most of the stuff that we need is kind of in long-term memory. We pull it out to the desk, we put it back into long-term memory, but our desk is about 4 chunks. If we rehearse it, then that starts to go into long-term memory. And so then it's becoming encoded. Long-term memory, we really haven't found a cap, okay? So it's pretty unlimited capacity. But it's not as accurate as sensory memory or short-term memory, okay? So when you remember something that happened to you when you were a child, you're going to remember it differently than somebody else. And part of that is because you both are having inaccurate memories. As we talk about memories through this chapter, both in class, Launchpad, and in this video lecture, you'll see that we're not always very great at remembering things in long-term memory. Our long-term memory is kind of this organization and storage system. Again, it's kind of that filing cabinet where we're keeping this stuff. Information is not stored in precise locations. We see biologically that it's stored kind of throughout the brain. There's not just one area that we see memories are stored in. And the duration, how long do we keep these memories? There's some evidence that these may be permanent. And when we don't remember things, it's that we're not getting an accurate cues to recall it. So again, we don't really know. We haven't found a cap for how much storage we have in long-term memory, and we haven't found a cap for how long we can store something. Somewhat of what we find is really that it kind of depends on the context, which we'll talk about later, on remembering these things. So there might be something that you haven't thought about for a very, very long time, and you hear a song or you smell a smell, and all of a sudden that jogs a memory that you haven't thought about in, it could be decades. And again, you haven't thought about this. This isn't something that's been rehearsed, but it was attached to this song, it was attached to this sound, it was attached to something else, and that context of that sensory information really brought back that long-term information, that long-term memory. So again, kind of as a recap, sensory capacity is really, really huge according to this Axis and Schriffen model, but the duration is very, very brief. If we don't put it into working memory, short-term memory, it's gone. And it's forgotten. Short-term memory, working memory, again, it's got a limited capacity, about 7 units plus or minus 2. The duration's pretty small too, so 15 to 30 seconds. So we're not talking about kind of a long-term kind of a situation. And then long-term memory, again, we haven't found a cap for capacity, and we haven't found a cap for duration. So right now, our current understanding of both of these is that there isn't a cap, that these approach infinity, because we have not found evidence of either a cap for how much we can store in terms of capacity or how long we can store it in terms of duration. So working memory or short-term memory, the term working memory was really kind of coined and brought to prominence by Alan Badley. And this, what he talked about is this is active processing of information. So this is when we're actively using things. This desk that we have in our brains. And what's really nice about this desk is that it allows us to associate new and old information. And you'll see as we move forward in discussing memory, if you already know something about whatever it is you're learning about, it's easier to learn new stuff about it. So it's really, really easy for me to learn new stuff about psychology because I know a bunch about psychology. So incorporating new information in my working memory is really easy. I can take the new information that I have that came in my short-term memory, my working information memory, I can associate it with something in my long-term memory. And that really provides really good encoding. So I'm able to remember new information a lot better because I already know a lot about that. Something that you maybe know a lot about, whatever it may be, whatever your area of interest is, whatever you kind of like to nerd out about, like I like to nerd out about psychology, you'll find the same thing. When you learn something new about it, it's going to be a lot easier to remember that than somebody who doesn't know anything about it. So my husband right now is very into home brewing beer, and he knows a lot about it. And when he reads something new, that information is encoded very easily. When he tries to tell me about it, somebody who really doesn't know a lot about home brewing beer and really not that interested in home brewing beer, it's harder for me to remember that new information because I don't have that same point of reference that he does. Working memory is also where we solve problems. Again, this is both using the new incoming information and also that access of that longer term information. So there's also other kinds of information, other kinds of memories that we will talk about some more in class as well. But I want to briefly touch on them in terms of encoding. So when we automatically process something, it goes into what we're going to call implicit memory. Implicit's when you know how to do something. So remember in class I gave you the example of knowing the code for the graduate lab when I was in graduate school. I couldn't tell you the numbers to save my soul, but I could get in there. I had this automatic, unconscious encoded information of which keys to press on the keypad to get in. I did not know what numbers those were, but I knew what keys to press. They went in and they changed the keypad, and the numbers were the exact same, but because the keypad was new, I didn't know that information anymore because I had this implicit unconscious information. And again, we see this as happening automatically. This is not something that we're necessarily putting a lot of effort into. Implicit memories are these automatic processing. And so we're storing information kind of without meaning to. Effortful processing, when you're studying for an exam, when you're trying to memorize something, you're engaged in effortful processing. You are trying to remember this information. You may be doing it through rehearsal, saying it over and over again, reading it over and over again. You may be doing it through other kinds of effortful processing that we'll talk about. But this is where our attention is focused, our consciousness is focused. And we're trying to remember this. And that's what's happening with explicit memories and effortful processing. So the deeper level of processing, the longer lasting the memory. So the better we encode this information, the deeper we encode this information to begin with, the longer we're going to remember it. So if I asked you to remember a list of words and you thought about kind of how the words sound or kind of how the words look, you're not going to remember those words very long. However, if you are thinking about their meaning and associating those words together, you're going to do a lot better job of memorizing them. You're going to have better processing. You're going to be engaged in deep processing because you really are emphasizing the meaning. And that's one of the reasons that for my exams that we try and do things that do require this more higher level kind of processing. I want you to be engaged in this semantic processing. I want you to know what it means. I don't want you to just memorize the word order of the definition. I want you to know what that definition means. I want you to be able to tell me what that definition means, and I want you to be able to apply that definition into a different situation, because that's a higher level kind of learning, which is going to serve you well no matter where you end up, regardless of if it's related to psychology or not. That learning, that deep level of learning is very, very beneficial. So again, the best way to remember something is to engage in this deep processing. And again, we see this in terms of research studies. So this was a research study where they were tried to remember about they were trying to recall words, recognize words. And when they thought about the word's meaning and they thought about judgments of the word, when they made these semantic judgments, they recalled the words about 85% of the time. When people rhymed with the words, so when they did rhyming, they only, and this is again attending to the word sound, this was shallow processing. They only remembered the word about 55% of the time. And when they just paid attention to what the word looked like, they just used visual judgment, then they only remembered the word about 15% of the time. So we really see that this deep processing by using the semantics and understanding meaning really results in better memory. Other kinds of memory devices, such as mnemonic devices, one of which is an acrostic. I use this one, please excuse my dear Aunt Sally, pretty frequently for my statistics students when we're doing some of our formulas, okay? So I use this to remember that parentheses come first, then exponents, then multiplication, then division, then addition, then subtraction. So this is how I use to remember the order, and this is how I remind my students to remember those order of operations as well. Because it's an easy way to remember the letters. It's a lot harder. We know we're not good at just memorizing random orders of letters. So just memorizing P, E, M, D, A, S is a lot harder than memorizing, please excuse my dear Aunt Sally, which has more of a meaning attached to it. Acronyms are another example. SCUBA is an example of an acronym, and it actually stands for Self-Contained Underwater Breathing Apparatus. And again, this contains a lot of information. Other things that we use to remember things, rhymes. I before E except after C is another one that I use fairly frequently. Spelling is not my forte, and I have to use this one an embarrassingly large percentage of the time in words involving I and E, especially when there's a C. Visual imagery is another way that we do this, and we've got some examples of these on subsequent slides, such as elaboration is one way. Another way that we can remember things is organizing that information, and one way we do this is categorical clustering. So here is elaboration, and elaboration is again a kind of effortful processing. We're trying to remember this information. And so in elaboration, we may create a shared relationship between two or more pieces of information that don't really relate a lot. So if I'm trying to remember the word fish and pipe, these don't really have a lot in common. I might elaborate this by making the imagery of a fish smoking a pipe. I've used this fish smoking a pipe picture for several years now, since California even, and I have no problem remembering what words that we're going to talk about for my example as I lecture, because I have this image of this silly fish smoking this pipe. And so it really does make it easier for me to remember these two words that really have nothing in common and really don't do me any good to remember. But because of this elaboration technique, this effortful processing technique, I can remember these. Another example is categorical clustering. So if you're trying to remember your grocery list and you need to get apples and dish detergent, milk, frozen vegetables, bananas, cheese, ice cubes, bleach, grapes, yogurt, and glass cleaner. One way that you can organize this and to remember this is by putting them into categories. So fruits, you need apples, bananas, and grapes. Frozen fruits, you need frozen vegetables and ice cubes. Milk, for dairy products, you need milk, cheese, and yogurt. And for cleaning products, you need dish detergent, bleach, and glass cleaner. Again, by organizing this stuff, it's a lot easier to remember than if you were to just leave them in the original order that you made the list. So this is something that actually develops. Categorical clustering is not something that we just do at birth. We start out by simply rehearsing information. So we would get that grocery list and we're like, okay, let's just repeat it back. Just say it over and over and over again. But as we develop, as we develop more cognitive functions, we really can start to group these items together through these related objects. Here's a video about it.
Between the ages of 5 and 11, children develop new strategies to retain information in memory. When given a list of 10 words to remember, 10-year-old Drew repeats or rehearses the words to himself, but in the same order as they were presented.
Dog, apple, cat, banana, horse, orange, duck, and grape. Those words?
Dog,
apple,
cat, grape, banana.
Jenny, on the other hand, uses a more efficient rehearsal strategy, grouping the words according to meaning, and is able to recall more of the words from the list.
Dog, cat, horse, apple, banana, grape, and orange.
So again, she engaged in this effortful processing. She used those semantics and she had this deeper understanding of those words. She remembered them a lot better than the boy that just rehearsed them in the same order that they were given. He was trying to kind of go more off of those sounds, a more shallow processing, and we saw that he didn't have that same level of retention. And again, we see this as something that changes over development. This is something, as the video said, that changes. So other encoding techniques, I mentioned that knowledge base affects this memory performance. So because I know a bunch about psychology, it makes it easier for me to learn more about psychology. So that's why sometimes the hardest classes that you sometimes take are your introductory classes. I know that doesn't make you feel good because you're in my intro psych class now, but because you don't have as much to relate it to. At least with psychology, you're able to relate it to your own life. And so that can make it easier to remember it. The more we know about a topic, the easier it is to remember new information because it's more familiar and it's easier to learn. So there's been several studies that have looked at this. Some looked at chess experts and novices. Some looked at soccer experts and novices. And there's a lot of different ones like these. And what they did is they had some really random, for the chess, they had some random order chessboards. So these weren't like a known kind of play. These were just a random order of chess pieces around the board. And they asked both chess experts and chess novices to remember them. And what they found is that the chess experts remembered these a lot better. They had a lot more experience with chess. So they could relate it to stuff that they already knew. They could relate it to games that they'd played. They could relate it to techniques that they learned. They could relate it to these other things. Whereas the novices, I would fall into that category, had a really hard time remembering this placement of these chess pieces because they didn't have that same level of information to associate it with. So again, this is kind of that relationship between long-term and short-term memory. Because the chess experts had a lot of chess information stored in long-term memory, it was easier to encode that new information that was in working memory into long-term memory because working memory could associate it with something it already knew. Whereas the chess novices, the people that didn't have a lot of experience with chess, had a lot harder time taking that information in working memory and putting it into long-term memory because there wasn't a reference point for that. We see the same is true with soccer experts and novices. So again, kind of memorizing a series of plays. We see the experts are going to be a lot better at that than the novices are. And we see these in many, many areas. So that again, when you already know a bunch about something, it makes it easier to learn new information about that same topic. So if you're struggling to learn this psychology information, again, one thing that you can do is relate it to stuff you do know. So relate it to things about your life, and that's one of the reasons that we did that that timeline for the lifespan chapter, is I wanted you to relate the topics that you learned back to that timeline that you created. I wanted you to kind of take that information that you were trying to encode into long-term information and have something to associate it with. Because we see that the more that you can associate new information with other memories, the better that information is encoded. There are also different types of memories as well. Event memories, and we have scripts for these events. So if I ask you what happens when you go to a restaurant, you can tell me step by step what happens when you go to a restaurant. And you can tell me that it's different at a fast food restaurant versus a sit-down restaurant. You can tell me these different situations. You can tell me these scripts for familiar events. Washing a car, the same thing. You can tell me these things. If you are really good at washing a car, if that's something that you really like, you're going to have a more detailed script because, again, that's something that you're very interested in. You have more knowledge on that. If it's not something you really do a lot, if it's not something you're very interested in, you're going to have a more simplistic script because it's not as a familiar of an event. Constructive memory. This is, again, how we're interpreting this information in terms of that previous information. So when I was talking about taking that information from working memory and associating it with long-term memory, we're talking about constructive memory. We're constructing this information to encode it better. We also have autobiographical information. We've talked about this a little bit in our lifespan chapter when we talked about the development of autobiographical information. But autobiographical information are these specific personal memories about yourself. We see that emotion is really, really linked to memory as well. So excitement, stress, or strong emotions can really strengthen the memories that we have. And we find that this is very, very adaptive. If you're in a good situation and you're excited, you want that thing to happen again, right? And so remembering how that happened, the order of events that left up to it is important. If you're stressed out, if you think back to our evolutionary past, if you were in a situation where you were unsafe, and even now, if you're in a situation where you're unsafe, remembering the details about that is very adaptive so that you can avoid those unsafe situations in the future. So again, we see that this is adaptive. We see that this emotion triggers stress hormones, which increases the glucose production, which is helpful because glucose is sugar, right? And our body essentially runs on sugar. So it signals the brain that something important has happened, and the amygdala boosts the activity and the proteins in the brain's memory areas, okay? So the amygdala is really, really important, we see, in forming these emotion memories because it's triggering that, hey, something important is happening. You need to remember this. So again, those hormones make sugar, increase the sugar production in our body, which tells the amygdala, hey, pay attention to this. This is something we need to know. So again, we'll see that that emotion and memory are linked. Your book talks about different situations where this can happen. We can talk about flashbulb memories. So some of you may remember kind of where you were when you heard about 9/11. I have memories of where I was when I heard about the Challenger explosion when I was a kid, which was a similar kind of big deal thing from when I was a kid versus when you guys were kids. I remember where I was when I heard about the Twin Towers. I was in college, and I was in my bedroom in my apartment, and I was in the smallest of the 3 bedrooms. I shared it with 2 other girls, and it was so small that my TV was in my closet. And I remember being on my computer, and one of my friends from high school, I'm going to date myself here, sent me an AOL instant message and said, "Hey, did you see what happened?" And so I immediately turned on the news, and I remember all the details of where my furniture was, who messaged me what, kind of the actions I went through, because it was a highly emotionally triggered situation. There was something serious happening, and it strengthened those memories. Other ways that we can kind of access memory or increase memory or change memory, one of these is priming. So priming is when we activate an existing memory by a stimulus, and then that can unconsciously change what we're going to associate it with later. So a good example would be you hear or you see the word rabbit. This activates this little picture, this idea of what a rabbit is. Later I give you the word hare. You are more likely to associate that with like the tortoise and the hare, H-A-R-E, than you are to associate it with the hair on your head, because we've already activated this concept of rabbit. And so again, it's going to be easier. You've been primed to think about hair, H-A-R-E, instead of hair, H-A-I-R, because we've activated this idea of a rabbit. So priming is something else that we see is a memory function, and we see lots of really interesting studies on as well. Some of our information that we know about memory has come from lesion patients. Lesion patients are people that, again, have had injuries to their brain, whether it be something that was medically induced or whether it be an accident. But again, they have these brain injuries. And was a very famous example of this. He suffered from epileptic seizures. And it wasn't until after he died that we knew his full name. He was protected and called HM for a long time. But he suffered from epileptic seizures. At 27, he had part of his temporal lobe removed to prevent these seizures. HM had explicit memories from before the surgery. So he could remember at 27, what he learned in college, what his wedding was like, any of these explicit memories that telling you that, he could tell you any of that information from before his surgery. However, he could not form new explicit memories after his surgery. He couldn't tell you if his kids were born after 27. He wouldn't have been able to form explicit memories of kind of how that birth went, any of the information around that. He wouldn't have been able to learn new memories, so he wouldn't be able to, say, take a college class and learn a whole new topic. That's not something that HM could have done. So HM could recognize himself at pictures at age 27, but as he got older, he could no longer recognize himself in a mirror because he remembered what he looked like before the surgery, and he couldn't change his memory. He couldn't form new explicit memories, so he couldn't encode what he looks like now. He lost explicit memories for events that happened after the surgery. So again, any kind of life event, any kind of new information that he tried to learn, he was unable to remember. However, he did retain his implicit memory. So again, that stuff that's that automatic processing. So what was really affected here was his effortful processing, that focused attention to remember something. That's what was lost. But that implicit memory, we saw there was no differences in that. So he performed normally on procedural and priming tasks. Because again, his implicit area was not affected. One of the major areas that was removed was his hippocampus. And what really, what HM really taught us was that the hippocampus is very, very important in the formation of explicit memories. How important of a role the hippocampus plays in encoding this information. Now, again, we're not talking about storage. We're not talking about retrieval. We're talking about encoding. So that the hippocampus is playing a really big role in processing these explicit memories. And what it also told us was that implicit memories are really processed somewhere else in the brain, that they're not affected by the hippocampus the way that explicit memories are. So that ends our lecture for Chapter 8, our online lecture. Again, I will we'll continue to discuss this in class next week and do some in-class activities. See you in class.